Alright, so here's the rest of Review E. We're going to look at number 21. It says write a function g given the transformation on the graph of f of x is negative 5 square root of 2x plus 3 plus 7. 21 says a horizontal translation left 6. So when we go left, that's plus, so f of x plus 6, because horizontal is on the inside. It looks like a B. That means I'm plugging x plus 6 into the equation for the x. So negative 5 square root of 2 times x plus 6 plus 3. Then you got the plus 7 on the outside. Distribute 2x plus 12. So negative 5 square root of 2x plus 15 plus 7. What's your final answer? Okay, don't forget to plug it in and distribute the horizontal shrink that's already there. Number 22, taking the same equation, negative 5 square root of 2x plus 3 plus 7 on the outside. We're going to do a vertical translation down 4, followed by a reflection in the x-axis. So a vertical translation down 4, that's f of x minus 4. So I take the whole equation and subtract 4 off of the end. So I get negative 5 square root of 2x plus 3 as well. And then reflection in the x-axis is negative f of x. So that means I multiply the whole thing by a negative. Don't forget to distribute the negative to this out here. That's what everybody's making a mistake. So make sure we change the sign on that. So we get positive 5 square root of 2x plus 3 minus 3 as our final answer. Alright, so we're on the back side, solving equations and inequalities. Number 23 says, let's put some black on, x minus 3 equals the square root of 2x plus 29. So when I have a square root on one side, to solve, I square both sides. There's one right there. And the square on the right gets rid of the square root. And so I get 2x plus 29. And then off to the side, you should be taking x minus 3 times x minus 3. And we get positive 9, negative 3x, and x squared. So we get x squared minus 6x plus 9. We should be getting really fast at doing those, squaring the binomials, and even memorizing them at some point, because we've done them so much. Now I need to get all my variables on one side, so minus the 2x and minus the 29. So x squared minus 8x minus 20 equals 0. And now we want to factor what two numbers multiply to negative 20 and add to negative 8. That's going to be x minus 10 and x plus 2. So then we get x equals 10 and negative 2. Now when we have variables on both sides, we have to check for extraneous solutions. So we're going to plug it in and see if it works. First, 10 minus 3 equals the square root of 2 times 10 plus 29. 7 equals the square root of 49. Check, that worked. And then negative 2 minus 3 equals the square root of 2 times negative 2 plus 29. And there's our issue. That's negative 5 equal to the square root of 25, which is not true. So negative 2 is extraneous. So my only answer is the 10. Number 24. 2n minus 6 to the 1/3 power plus 9 equals 5. So I have to get the 2n minus 6 to the 1/3 by itself. So I'm going to minus 9. I get 2n minus 6 to the 1/3 equals negative 4. And to get rid of the 1/3 power, which is the same as the cube root, I'm going to cube both sides. So 2n minus 6 equals negative 64. Add the 6. 2n equals negative 58. Divide by 2. And n equals negative 29. And if I look at that and plug it in, just to make sure I did it right, we don't have extraneous solutions on the cube roots because there isn't a domain restriction, but it never hurts to check to make sure you did the problem right. 2 times negative 29. So if I don't get the right answer here, if it doesn't work, that means I did something wrong, not that there's anything extraneous. To the 1/3 plus 9 equals 5. That's negative 58 minus 6, which is negative 64 to the 1/3, which is negative 4 plus 9 equals 5, and it works. So I did the problem correctly. Number 25. Square root of x minus 15 equals 3 minus the square root of x. So this is one where I'm going to have to use the square twice. First time I square gets rid of the square root on the left, so I get x minus 15. But when I square 3 minus square root x, 3 minus square root x, I end up with positive x and negative 3 square root x, negative 3 square root x, and 9. So we end up with 9 minus 6 square root x plus x. Then we want to get this square root of x by itself, so I'm going to subtract the x and subtract the 9. So I get negative 24 equals negative 6 square root x. Divide by the negative 6. And 4 equals the square root of x. And we'll square both sides to get x equals 16. Now let's go back and make sure it works. Square root of 16 minus 15 equals 3 minus the square root of 16. And we end up with square root of 1 equals 3 minus 4. And 1 does not equal negative 1. So there's no solution because my one solution didn't work. Okay, let's go on to number 6. We have 7 times the cube root of x minus 3 less than or equal to 21. So the cube roots don't have a domain restriction because I can take the cube root of a negative. So I'll start by dividing by 7. And I get the cube root of x minus 3 less than or equal to 3. I'm going to cube both sides. My stylus doesn't want to work tonight. and I get x minus 3 less than or equal to 27, and add 3. So x is less than or equal to 30. And I can look at it and make sure it works. 30 minus 3 is 27, cube root of 27. Cube root of 30 minus 3, 7 times that, that's 7 times cube root of 27, which is 7 times 3, which is 21, which is less than or equal to 21. So I did it right, and my answer is x is less than or equal to 30. Let's look at 27. 4x to the 3 halves power plus 6 equals 38. So we're going to subtract 6, and 4x to the 3 halves equals 32. Divide by 4, and x to the 3 halves power equals 8. And then when I have the 3 halves power, I raise it to the reciprocal. So I raise it to the 2/3 power 2/3. So x equals the cube root of 8 squared, which is 2 squared, which is 4. And we want to check that to make sure it works. 4 times 4 to the 3 halves plus 6 equals 38. 4 times the square root of 4, that's the 2 on the bottom, right? Square root of 4 cubed, the square root of 4 cubed, that's 2 cubed, which is 8. So 4 times 8 plus 6 equals 38. Yes, we did it correctly. So our answer is x equals 4. And the last one was x is less than or equal to 30. Number 28. The 3 times the square root of 2x plus 10 minus 6 less than or equal to 18. Now when we have an even root, we need to look at the domain restriction. So we're going to start over here, and we're going to look at 2x plus 10. That has to be greater than or equal to 0, or it's undefined. So minus your 10. 2x is greater than or equal to negative 10. X is greater than or equal to negative 5. So that's going to be the lowest number, the smallest number that x could possibly be. So now, when I solve this, I can add 6. I get 3 times the square root of 2x plus 10 is less than or equal to 24. Right. And then divide by the 3. The square root of 2x plus 10 is less than or equal to 8. Now to get rid of the square root, I'm going to square it. So I get 2x plus 10 less than or equal to 64. Minus the 10. 2x is less than or equal to negative, or 54, not negative. Divided by 2. X is less than or equal to 27. So I'm going to put together that restriction with which, if I flip it around, says negative 5 less than or equal to x, and then less than or equal to 27. So that's our final answer. So it's really important when it's an even root, and a less than. Well, all even roots, you should look at the domain restriction just in case, but especially when it's less than, it's really important that you look at that, because we're going to mark you off if you don't have a second domain restriction. All right, that gets us through our solving equations. Let's look at the composites. Number 29. A, B, and C, so I'm going to write down f of x equals x squared plus x. G of x. It says g of n, but it's supposed to say g of x, negative 3x plus 2. And h of x equals 4x plus 1. So A asks us to find f of g of h of x. Nope, sorry, wrote it wrong. Of -1. Now when the number here is a number, we're just going to start plugging in 1 and we should get a numerical answer. When this is a variable, then I should get an equation for my answer. So when I plug in -1, I start with -1 and I first go to h. So h of -1 is 4 times -1 plus 1. And h of -1 equals -4 plus 1, -3. Then it says to go to g. So let's do that in a different color. G of -3. So I take what I got from the first one, I plug it in to g. -3 times -3. Oh, that didn't work out for me. -3 plus 2, which is 9 plus 2, which is 11. And then g into f. So I'll do that in black. F of 11 is 11 squared plus 11, which is 121, plus 11, which is 132. So A is 132. Let's look at the difference in B. B says g of f of x. It says n. Again, we're going to replace those two n's with an x. F of x, that means I'm going to plug f of x into that g of x. So g is -3x plus 2, and f is x squared plus x. So we get -3x squared minus 3x plus 2. And that's our equation. So that's your final answer. You don't have to do anything else to that. And C is g of h of x. So we're going to start with h. And h is going to plug into g. So this time, this h is going into g. So again, -3x plus 2. And what we're plugging in is the 4x plus 1. So -12x minus 3 plus 2, -12x minus 1. And that's your answer. Okay, so if your parenthesis here is an x, or what's inside here is an x, your answer should be some kind of equation. And if it's a number, your answer should be numerical. All right, so now we're on to the inverses section. Find the inverse of each function. A, so 30a says f of x equals 3x minus 2 divided by 5. I want to find the inverse. So the first step to finding the inverse is changing my f of x to y. I switch my x's and my y's, so I make it x equals 3y minus 2 over 5. And then I get y by itself. So I'm going to multiply by 5. So we get 5x equals 3y minus 2. I'm going to add 2. So I have 5x plus 2 equals 3y. Then I'm going to divide it all by 3. I'm going to write it as separate fractions, 5/3 x plus 2/3. And that's the inverse for A. For B, if g of x is -5, 0, 3, 6, and 0, -4, this should be the easiest problem on the test. We take our x's, and we put them where the y's are, and we take our y's and we put them where the x's are. We just switch it around. So my inverse, G inverse, is 0, -5. The signs stay the same. 6, 3, -4, 0. That's it. And number C, letter C, 4x squared minus 6. Again, make it y equals 4x squared minus 6. Switch your x's and y's, and get y by itself. So I get x plus 6 equals 4y squared. I get y squared equals x plus 6 over 4. And then we take the square root. Y equals the square root of x plus 6 over 4. And plus or minus. There was no domain restriction, so the inverse may not be a function, but this is the proper inverse. And then I can simplify this a little because what do we know about the 4 on the bottom? It's a perfect square. So y equals plus or minus the square root of x plus 6, and the square root of 4 is 2. So there is my inverse for part C. And 31, f of x equals the cube root of 2x, and g of x is 8x cubed. And it says use the composites to prove or disprove if the functions are inverses. So we want to check f of g of x, which means I'm going to plug g, 8x cubed, into f. So the third root of 2 times 8x cubed.
Are you talking to yourself?
Okay, when I simplify this, I get the cube root of 16x cubed. The cube root of 16 simplifies to 2x cube root of 2, which is definitely not just x. So they're not inverses. In order for them to be inverses, everything needs to cancel out except for the x. Now, number 32 says f of x is -2x plus 6, and g of x, -1/2 x plus 3. So let's try f of g of x. So -2 times -1/2 x plus 3 plus 6. -2 times -1/2 is positive x. -2 times -3, using the distributive property, is -6, plus the 6 is x. So that one worked. Let's try g of f of x. So that's -1/2 times -2x plus 6 plus 3. We're going to distribute 1/2 times -2 is positive x. -1/2 times 6 is -3. -3 plus 3 is x. So yes, they are inverses. And last problem, number 33, h of x equals -square root 1/2 x minus 1 plus 3. Now this one, it says using a table. Usually when we have a horizontal shrink or stretch in there, that's that 1/2 horizontal stretch, factor of 2. We choose to use the table instead of trying to use transformations. So the first thing I'm going to do is look at my domain restriction. Has to be greater than or equal to 0. With the radicand, add 1. 1/2 x is greater than or equal to 1 times by 2 x must be greater than or equal to 2. That's a 2. So that's where my table is going to start. I'm going to plug in 2. When I plug in 2, I get 0 under the radicand, right? I just found out what equals 0, so this is 0. Negative 0 plus 3 gives me 3. So my starting point is here at 2, positive 3. Now I need to pick another number to plug in. Has to be greater than 2, right? So I can't plug in 0. And you can see if I plug in 0, I'd get a negative under there. So let's try 4. Let's use evens. Negative square root of 1/2 times 4 minus 1 plus 3. Negative square root of 2 minus 1. Negative square root of 1 plus 3 is positive 2. Okay, so that's the point 4, 2. And let's try to find one more. So I skipped 2 numbers. Let's try 6. Negative square root of 1/2 of 6 is 3. 3 minus 1 is 2. I don't want to take the square root of that, so I don't want to use that one. Let's look a little bit closer. I want 1/2 x minus 1 to equal 4. So I need it to equal 1/2 times 5. Okay, I'm thinking if we plug in 10, that's going to work. And what I did in my head was I just kind of looked through. I said 6, 1/2 of 6 is 3, 3 minus 1. And here I said 1/2 of 6 is 3, 3 minus 1 is 2. 1/2 of 8 is 4, 4 minus 1 is 3. 1/2 of 10 is 5, 5 minus 1 is 4. Oh, there's one that I can use. So 1/2 times 10 minus 1 plus 3. That's negative square root of 4 plus 3, which is negative 2 plus 3, which is 1. So let's see, what have I got here? I have 1, 2, 2, 3, 2 positive 3 up here. Then I have 4, 2, and 4, 5, 6, 7, 8, 9, 10, 1. So notice it's down because of that horizontal, or that reflection over the x-axis. So we have a domain of x is greater than or equal to 2, x such that, some curly braces around there, in my range, y such that y is less than or equal to positive 3. All right, guys, that's all I can do. It's all on you at this point. Good luck.